and welcome to a special Christmas episode of the Super Circuit Bending Super Show. As you might guess, we're going to take a crack at circuit bending this fuzzy moose head. This guy I picked up at like a thrift junk antique store in Santa Rosa, I'm going to say, or on our way to there. And I bought this and an old VHS camera from the guy, and he told me they both worked, but he lied. Neither of them actually work. So this guy, unfortunately, is busted, and I'm not sure what's wrong with him. But that's kind of the risk you run buying deep discount electronics. Sometimes you don't always work with the, most honest and helpful folks. But that's okay. We got this guy really cheap, and I think we can potentially either figure out what's wrong with him and get him fixed up, or go a completely different route. Now, my understanding is he used to be kind of like one of those big mouth Billy Bass things, but just Christmas themed. He's got right here this little IR sensor, so I think when you walk by, he would detect the motion and start singing. Feels like there's a motor in here, so I'm guessing his mouth would move along as he sings. And returning viewers may notice a Christmas present to myself. I got a new soldering mat that I did not drill holes in by accident. So this one's nice and big, and I think is going to be super nice going forward. But anyhow, since I'm not at all sure what's wrong with this guy, or what's gonna be going on, and I'm not particularly interested in making it work on him. And if I'm being completely honest, I also did not plan my Christmas episode far enough in advance, so I'm kind of scrambling to get this done on time. So in the interest of all of that, what I'm gonna do is I'm gonna take it off camera to see if I can figure out what's wrong with him. If I fix him, I'll come back and report back. And if I don't fix him, I'll come back if I have a different idea on what we'll do. And if I can't think of anything to do and I can't fix him, then no one will ever see this video, so that's totally cool too. So I'm gonna take a cut here, and hopefully in a bit I'll be back telling you all what was wrong with this guy. Okay, so I pulled all the electronics out of the moose head, and here's all the extra bits over here. And I'm not sure what's wrong with it. It's got pretty much most of the circuitry in a little silicon blob, so nothing else really looks wrong. If I was really like, I gotta fix this thing, I would probably test out the transistors and stuff like that, but I'm not too heartbroken about it. So I pulled this all aside, and what I think I'm gonna do is keep the little speaker and its enclosure, and I'm gonna repurpose the thing to basically be a Bluetooth powered player. Now, I tested the motor in the stuffed animal's mouth, and that still works too. So I think the ultimate concept would be, we're gonna rig up this Bluetooth to the internal speaker, then we're gonna rig it up so that the audio coming out of the Bluetooth controls the motor on the mouth. So basically it'll just hang on a wall. You can play whatever music you want through your phone, and the music will play and he'll sing along to it. It'll be a fun little thing. This is kind of a cool all-in-one Bluetooth module. It's marked as an HW406. There's a few different cheap Bluetooth modules out there. The upside of this one is it's all-in-one, meaning it's got an amplifier built in. And the downside of this one that I've looked at in the past is if you want like onboard controls, this one is not great because there's nothing for like changing the volume, skipping tracks, no controls at all. But for a project like this where we want to hang it on the wall and control it remotely anyway, this one's pretty ideal. There's a few things like I don't quite understand. Number one being, does it like turn off on its own? Or do we need to add like a power switch? And just testing to make sure we can sum the left and right signals to come out of one speaker without anything exploding. So that's what I'm going to do right now. And the best way to do that, I think, I'm just going to solder some little attachment points that I can use to clip things on and experiment with. So, first things first. I said that. Now I don't know what the first thing is. The first thing I'm going to do is set up the summing. Basically, we're going to take our left and right signals and we're going to run them. Think of it as like a V pattern. We're going to have left, right. They're going to go through these resistors and then be joined together into a single mono signal. And what the resistors do is they keep the audio signal from cross-talking between the left and right. That way they just unite and can come out one speaker. Now there's some types of amplifier where you 100% cannot do that and it will blow up, and we're going to find out if this is one of those types. So I've got my 220 ohm resistors hung from here, and those are connected to the positive left and right outputs. I'm going to get those soldered in. Here comes the fan. So I did that out of frame. What I did is I've used those two component ends to basically create little leads for the ground and 5-volt connection. Now, I keep a box of old clipped leads on my desk because they definitely come in handy. So I'm just going to grab one of those and put it through. I tested earlier, and I know that the left and right negative are already connected on the board. I'm just going to go ahead and run a little lead through one. So I'm going to get those soldered in place, and I'm also going to solder the ends of these two resistors together while I'm at it. So here comes the fan. So that has us in a good spot where we can start testing everything out that we need to test, just using kind of clips to put everything together. So the first thing I'm going to test is the audio summing and make sure we don't just immediately pop the amp. So if any sizzling happens, I just need to pull one of these wires. This test, before we bring in the battery power, I'm just going to power it using the onboard 5 volts, which comes from a USB micro. And we don't seem to be getting anything resembling explosions happening, so that is also good. The last thing I want to test is just to do a stereo test to make sure we're getting both left and right.
You should be hearing this out of only the left side. You should be hearing this out of only the right side. You should be hearing this from both sides.
So we are getting both through. We are getting a better signal from the left, presumably because that's where our ground connection is. So I'm trying to recall, I think we're not supposed to cross the grounds, but maybe if we use resistors we'll be okay. Yeah, let's give that theory a test. I have a spare one of these little Bluetooth modules. They're pretty cheap. So worst case scenario, if I do blow it up, that'll be something we can talk about in the video. So I will do it for science. Did I say that? Knowing that, yes, the actual scientific way would be to, research it and understand the theory on how these little power amps work in the first place, but that is less fun than just seeing what happens. Alright, here comes the fan. Okay. So we've got the two separate grounds coming off our board, going to two separate 220 ohm resistors, basically doing the same thing we did with the hot to the ground to see if we can get away with that. Here we go, let's see if anything goes pop.
You should be hearing this out of only the left side. You should be hearing this out of only the right side. You should be hearing this from both sides. Left, right, both.
Actually, before I took that all apart, I am actually going to see if I can use a lower resistance. Because that was pretty quiet. Now let's see if we can get away with the 47 ohms.
You should be hearing this out of only the left side. You should be hearing this out of only the right side.
So that's a little louder. I'm checking, or has been doing this and not saying why. This is the little amp chip. And I'm just poking it to make sure it's not like quietly getting hot and preparing to explode. But I think by using our resistors, we're summing things to mono, but we're not creating the dangerous crosstalk. Now the other thing I'm gonna do, I was using 220 ohm resistors before, just because that's what I usually use for this. But because it's kind of quiet and I don't want to deal with putting in another amp or anything, I'm actually just going to use 47 ohm resistors for all of these. So right now I'm firing up my desoldering gun. Again, you could do this with a desoldering pump. You don't need a fancy desoldering gun. I don't feel like that's a piece of equipment you need if you're interested in circuit bending stuff. It's super helpful for me being one-handed, but super not necessary. So what I'm going to do, I'm just going to take off all of these connections I made to the left and right speakers, and I'm going to put a 47 ohm resistor in each one of them. After that, what we'll do is we'll start working on creating the audio reactivity. So I'm going to cut here, and I'll be right back when I'm ready to do that.
Eventually.
So while I was away, I replaced these resistors coming out of my audio signal sources for the Bluetooth module. I actually lied. I ended up going with 33 ohm resistors instead of 47 ohm. And that's just because I have a bunch of these 33 ohm ones laying around that I need to use. So next up, we are going to figure out our audio-reactive LED. And the reason we need an audio-reactive LED is basically we're going to have an LED that blinks whenever the audio is going, and then we're going to have a photoresistor controlling the voltage that's going to the motor. So whenever this light turns on, that photoresistor will drop resistance and make the motor turn, so the moose guy's mouth will open. And that should make it kind of relative to volume by having the natural smoothing with the LED light going through the photoresistor. Or basically that setup is called a Vactrol. So this is my super cool breadboard. Love this thing. It's from Copper Sound Pedals. Highly recommend it. I've got my module wired in here so that it will get power from the breadboard, and because transistors confuse the crap out of me, I have a little cheat sheet for how I'm going to wire this up, and in post I'll make a nice graphic for that so you don't have to deal with my handwriting. I will talk you all through it as I build this, and then we'll find out if it works. I'm going to start with a 220 ohm resistor that is going to come from our positive rail up into our breadboard section here. And then into the positive leg of our LED. Next, we have our transistor. This is a 2N3904. This is where I was getting confused. So on my cheat sheet, I have it labeled so that if we're looking at the flat part, it should go emitter base collector from left to right. so the emitter should go to ground, where I've got this green wire here, and then the collector should connect to the positive end of my LED. I'm just gonna move this just a hair to make that connect, and left. I'm just making some little connection points that I can clip in the audio signal. And for these, I'm just using some leftover component legs. I know some people are very fancy breadboarders. I am not. I usually go very quick and dirty, and yeah, it usually ends up being pretty ugly. But that is fine. So we're going to connect the positive end of our audio signal to the base of our transistor, and then the negative end of our audio signal should go to ground. Alright, and with all of that set up, we should now be able to play music through the Bluetooth, and then as it plays, this LED should light in response. So I'm just going to plug in a 5-volt supply up here. I'm not sure why that's just staying on.
4 to 6 weeks later.
I had to make a couple of tweaks to my circuit, but now that I've got it figured out, I'm gonna talk through it, and in post I'll make like a nice looking schematic and throw it up on the screen here. So much like I had before, I've got a little Bluetooth module unit. These clippies here, I know they look really messy. Those are basically just connected, like we had before, to the audio out, positive and negative. Basically, we have the audio going to our little speaker that came out of the moose, and then we also have it going to the circuit on the breadboard. Now, like I talked about before, it's basically just a resistor, an LED, and a transistor. But what I had to change to get it to work properly and stop making feedback, so I had to isolate the power source of this Bluetooth module. These things can cause a ton of feedback, so having them on their own power is usually super helpful. In this case though, I want to power everything, all from the same little battery pack, so it just fits back in the moose. So instead I'm using this little opto isolator. What that does is it separates the power supply for this guy from the power going to this LED. So let's demo it real quick.
You should be hearing this out of only the left side. You should be hearing this out of only the right side.
And you can see now the light is much more responsive. We're not getting any weird sound either. The other thing I had to change, and I totally breezed past it earlier, I added this little capacitor between the audio signal, positive and negative, right here on the transistor. That'll be on the schematic as well, but I just wanted to point out that that was the other piece that really cleaned it up. So the next thing we're going to do is get this off of the breadboard and start building it onto an actual piece of strip board. But I'm going to see if I can actually get away with just using this little corner here. To start with our transistor, since that's kind of the centerpiece of the whole thing. Alright, then next up we have our little capacitor. This is going to go between the left and center pins of the transistor. There we go. After some fighting, I finally got that to stick. Next up, I've got the opto isolator here. What I'm doing here is just lining up the negative contact with where that's gonna go. Eventually go to on the transistor. Okay, so before this thing gets too loaded up, I'm gonna go ahead and solder these in. Here comes the fan. next up, I will do the LED. What I'm doing with the LED is just kind of bending it off to the side. That way when we make our Vactrol, it'll be a lot easier to access it. Okay, so what I've done is I've threaded a resistor through where our positive power connection is going to come through here, and out the same hole as the positive side of our LED. I get those soldered in place. Here comes the fan. Now I want to go ahead and attach my Bluetooth module here. Not really sure how I'm going to route the audio, but I'll figure that out here in just a sec. I'm going to use my little tweezers here. Clamp this guy up. Here comes the fan. I'm going to take a minute here to go ahead and clean this up a bit. These little wire ends are starting to get piled up. And next thing, this is where basically this is the power supply isolator. The negative power from the battery is going to come in here, and that's going to go up to this point. Here comes the fan. So next up, I need to make my audio connections. I think the easiest way to do that is just going to be to run some wires from here over to the point. Go ahead and get these ends soldered, and then we'll do the other side. Here comes the fan. And the last thing, I'm just going to run a couple of wires in that we'll use for our power. That'll make it easy to connect up later. So I'm just going to use red for positive, green for negative. And next, what we're going to do is just try this out using the actual battery pack power and see if it holds up in the real world.
You should be hearing this out of only the right side.
Alright.
You should be hearing this from both sides.
So our little module worked. And the next thing we'll do is just figure out a Vactrol, get that sized correctly to power the motor and the little moose guy. Now the last thing we need to do for the electronics for this guy is figure out what size LDR we need to use for the motor. So we already set up our blinking LED, which right now I've got hidden under this piece of tubing. And next up we're going to try to use different sizes of LDR and just kind of see how the motor moves and kind of pick what works best through trial and error. So to describe the setup, I've still got everything I built before with the audio circuit. That's all the same. But now I've got the wires for the motor coming out And I've got the negative motor just hooked up to the ground connection with everything else, kind of under his little scarf here. And then the hot connection, the red is going to the motor, and the yellow is coming from the power supply. And basically these two are going to go on our light dependent resistor. So when it's completely dark, there will be a really high amount of resistance between these two, and that should prevent the motor from moving. And then as the light turns on, as the music volume increases, that resistance will decrease, which should start the motor moving. So I'm starting out with a 5528 LDR. This has roughly a resistance between 10 and 20K, and a really high resistance, like a 1 mega ohm when there's no light at all. So how I'm going to test these, I'm going to put them in my little grabbers here, basically pop it inside that tube with the LED, and that will simulate how we're going to wrap it up as a Vactrol. So we're going to attach the yellow to one end, red to the other. And then in lieu of a power switch, I've just got this jumper wire that'll connect to the battery pack.
You should be hearing this from both sides.
Okay, so it seems like that resistance is a bit high.
346 minutes later.
Since my Vactrol idea is not working, I think I have one more idea.
Later.
I think I have figured this out. So basically the solution is to bring in one of these little PWM motor controller modules. These things are great. There's a bunch of good resources for modding tape players using these. And yeah, it's super simple to use. You just put power in one side, motor power in the other. And then as you turn this knob, you basically increase or decrease the motor speed. So instead, what we are going to do is we are going to add our little Vactrol light dependent resistor setup over here onto this to change the resistance when that LED we set up earlier goes. And that should create kind of a relationship between the music and the motor that moves the moose's mouth. That's a hell of a tongue twister. Motor that moves the moose's mouth. Anyway, I had this set up before to test it. If you consider that cheating, then I cheated. But I just wanted to show the wiring process because I figured that would be easier to talk through than trying to point it out in a mess of alligator clips. So the first thing I'm hooking up is the motor. So my red wire here, that is connected to my motor positive inside the moose. Black is motor negative, as you might expect. This small yellow wire, that is our power supply positive. That goes to the point marked DC in plus. The green wire, that's our power supply negative. Now over here, this clip is going to attach to the battery box. Right now I have it disconnected, so everything's shut off. And then these two clips I have attached to the end of my Vactrol. And those are just going to go between these 2 points on the motor controller. And by leaving the original knob in place, we can use that original knob as kind of a trim pot to adjust and get things just how we want them. Okay, I think I've got everything delicately balanced in the correct orientation. Let's grab our little stereo test.
You should be hearing this out of only the left side. You should be hearing this out of only the right side. You should be hearing this from both sides.
2 hours later.
You should be hearing this out of only the right side. You should be hearing this from both sides.
There we go. I think we've got that pretty well dialed in. Just as a reminder, it's kind of the opposite of what I would have thought as far as which pins on this you want to attach the Vactrol to. So what I'm going to do next is basically just rebuild this, but without all the clips. I don't think you will need me yakking through that, and I don't have a whole bunch of stuff to say. So I'm just gonna speed that portion up and do it in kind of one shot as I build it. Just a couple of things to note. I will be replacing this wire that I was clipping on and off the positive lead for the battery box. That I'm gonna replace with a switch. I'll probably try to mount that on the front here. And then once I've got that build done, we will test it out in its final form and see how it looks. You know, not a massive mess of wires on my desk.
6.5 hours later.
A super quick interlude, and then I'll get back to quiet build footage. As I was getting this put back together and doing a quick test run, I needed to make a couple changes to the design. The thing that was bugging me is whenever the music would pause, there was kind of a gap between when the motor would stop moving after the music stopped, and that was really annoying. What I found out I needed to do is put a resistor between the 2 points, the positive and negative leg of my little Vactrol LED. It's kind of hard to see, but where these two clips are basically across the positive and negative of that LED. And after doing, frankly, way too much testing, I found out that putting 95 ohms across the 2 points works out really nicely. Candidly, I should have just done 100 because I tried that and it worked, and then I spent way too long fine-tuning it, way too much. But, you know, that's how these things go. I can't remember if I was using 5539 or 5549s, but after trying it out with both values, again, I've decided to go with 5539. But anyway, give y'all a quick demo here to show you that with this resistor in, the motor is a lot snappier. So you can see it is much more responsive now. So what I'm going to do is finish the build up, adding in these resistors here. Just a quick check-in, as often happens, or at least as often happens to me. I got the build finished. I started to set up the last shot, like demoing it, and then I decided it's way too quiet and it's not going to work. And since the point of these videos is to show you the full process of projects, I decided, you know, it just wouldn't make sense to cut this part out or to ignore this part. So I wanted to show, you know, sometimes you get the whole thing done and you decide, actually, this sucks, I need to rework it. And the other thing, you know, for the purposes of the video, I was thinking, okay, you know, the mouth movement works and translates to camera, and I can just, you know, boost the audio on the, you know, video production side. But I feel like that would defeat the purpose, right? Because the point of these videos is to show you the whole process. So A, I'd be skipping part of that process, and B, showing you the full process for how to build a project that doesn't actually work would be pretty dumb and frankly really rude of me. So we're going to rework that instead. So what I'm going to do, I'm going to add in an LM386 amplifier board, and I'm not 100% sure of the wiring since we have the separate power supplies. So I'm going to experiment with the wiring on this thing to figure it out and report back. Quick check-in, I am going to carve out a little spot where I can put this LM386 module. I'm just going to be carving out a spot to put it with the Dremel tool. Alright, brilliant. So that fits pretty well. So I am going to take a minute to clean up all this stuff and then I'll get this guy all wired up. Alright, that white stuff got everywhere, but I think I at least got most of it. Yeah, now we've got a nice little hidey hole where we can mount our amp. And the next thing I'm going to do is go ahead and just get this guy wired up. And for this, what I'm going to do is use some shielded wire. And I'm using shielded here because with amplified signals, you're more prone to get interference. And so this will just help with any of that potential noise. Okay. So what I'm going to do is on the amp side, I'm going to run just an extra bit of unshielded wire to the input side. We're going to make the white wire our input and the red wire our output. So basically, yeah, we've just got to hook up input, output, and a ground connection. And if you've seen me use shielded wire before, you'll know our ground connection is going to be this sheathing. That way we've got kind of a grounded shield to keep the audio from having any kind of interference. So the first thing I'm going to do is attach our output and ground wires. And it's not a very good camera angle, apologies, but I'm just going to solder that from underneath. Here comes the fan. Next up, I'm just going to use a little bit of wire to extend my white input wire over to the other end of the 386 board. Here comes the fan. Good, now I'll just shrink that on real quick. Next up, I'm just going to get the other end attached. Alright, here comes the fan. Next up, we've just got these wires here. So I'm going to hook these up one at a time. Just to go over it real quick. The input wire, the white wire, is going to where our summed signal is coming out of the Bluetooth recorder at the end of these two resistors here. Then our amplified connection, the red wire, that's going to hook up to our LED using this other red wire, and it's also going to go to one of the speaker wires. Then our big ground connection, that's going to connect up to our summed audio ground. It's going to go to our LED ground, this green wire, and also to one of the speaker wires. That one's going to be a bunch of stuff kind of all blobbed together. Here comes the fan. And the last wire I need is I'm just going to set a wire up to provide power to our amp. I'm just going to set this up and solder this on at the same time that I reattach the original wires that I had cut earlier. Here comes the fan. Oh, I was about to say we're all done, but we're not. I also have to put this last wire so that we can turn on the amp. Here comes the fan. What I'm going to do now is kind of just plonk things down in here, give it a quick test, and assuming it works, I'm just going to jump to some footage of getting this all closed up, and then we will try this thing out. So my quick little test worked out, so I'm going to go ahead and get everything squared away, and then we'll give it a proper test demonstrating this thing. But while I am wrapping up, I just wanted to take a moment to say thanks so much to everyone who subscribes to the channel. It really is a huge help, and if you aren't already, just saying, you can do that now if you want to. But yeah, kidding aside, it does really help the channel grow, and really appreciate everyone who does that and has already done that. But what I'm going to do here, I've got my hot glue gun heating up, and I'm just going to secure all these wires in place. Pop that battery out to be safe. And I'm going to put a little hot glue down here just to make sure my little audio points are kind of close together. So I just want to make sure they don't accidentally drift and make contact with each other. The last thing, I'm just going to slap a bit of electrical tape over this area just to make sure nothing gets in there and causes a problem. Alright, I think we are ready to demo this thing.
To surgeon